Hello, Rochelle here. We're going to talk about graphing quadratic functions. So first we need to just remember what a quadratic function is. So a quadratic function is a function or an equation that has a degree of 2. So the highest exponent of the variable is 2. And this right here is our standard form for a parabola, where we just have the squared term first, then the x term, then the constant term. The other form that we will see for quadratics is what we call vertex form. So it's written in this factored form where hk is our vertex. We'll talk about what a vertex is here in just a second. Here are some examples of some quadratic functions. This one's obviously written in vertex form. This one is kind of written in vertex form and kind of written in standard form, and I'll explain that as we go forward. So there's two different ways that we can plot quadratic functions. Is we can either just plug in values for x, as I'm saying here. We just plug in the values that we choose for x, find the corresponding y values, and then plot the points and sketch the curve. Or we can identify key points like the vertex, the x, the y-intercepts to find the overall shape. So we're going to talk about both of those. First of all, we need to know that the shape of a quadratic function is a parabola that can either face upward, can be happy, or downward. And the highest or the lowest point is the vertex. So the vertex is either the highest or lowest point, depending on which way it's facing. So the highest point would be if it's facing like this. The lowest point would be if it was a happy one. The axis of symmetry, something that you'll hear about, is the axis by which, the function is symmetric. What that means is that the graph looks the same on the left as it does on the right. So if we're looking at this graph right here, if I take the mirror image of it and put it on the other side, it's going to be the exact same. So the x values are different, but the y values will be the exact same on both sides of that line. And the way that we label that line is it's going to be x equals, and then whatever x value we have here. So I'll just say that's a. So it's always going to be in the form x equals a number. Now, all parabolas will have a vertex and a y-intercept, right? The y-intercept is, for this one, is right here. The y-intercept for this one, is going to be up here somewhere. They don't necessarily have to have an x-intercept. In this case right here, there is no x-intercept. Over here, there are two x-intercepts. And there could also be just one x-intercept if the parabola just hits at the vertex. There would just be one x-intercept. So we're going to go ahead and look at how we would graph these. So I'm going to graph this one in both ways. So when I was talking about the fact that we could just plug in values, we could plug in some common values. Oftentimes, it doesn't matter what values we pick. We just want to make sure we find that vertex somewhere so we know where the graph, starts going back up or down. So we literally just take this point, -2, and we plug it in for the function. So we find f of -2. We square it, and we would get 4 minus 5, or -1 here. So this would be the point -2, -1. And then we can just plot that point. And we would do the same thing with all these other values. So I'm going to go ahead and do that a little bit over here. F of -1 would be -1 squared minus 5, or 1 minus 5, or -4. So this would be the point -1, -4, which is going to be right down here. If I plug in 0, I'm just going to kind of imagine if that was 0, I'm going to get out -5. So I'd have that point 0, -5. The cool thing is if I plug in 1, I'm going to pretty much have the same equation, because if I square -1 versus 1, I'm going to get the same value. So I'm going to get -4. So I can see that symmetry here. So I could actually imagine that this graph, is going to go right there. So I can go ahead and connect these. And there's my parabola. So my vertex here, you will notice, is at the point 0, -5. Now, I could have also imagined that, because remember, the vertex form looks like this. And realistically, I can put minus or plus 0 here. There's no number being added. It is always going to be the opposite value that I see here. So 0 and -5. Another thing to note is that because this term right here is positive, I know that it is going to be a happy parabola. So if I had the vertex just right here, I could get a very general shape, by just doing this. When I plug in the values, I get to see the more exact shape. So I would have known that it would have gone right through here. I would have got kind of the narrowness correct. So if we look at a graph like this is definitely not in vertex form. So we can go ahead and we can do the values. If I plug in 0, I'm going to get 6 out because I'm going to have both of these be 0. So I do know that 0, 6 is a point. And so we've already talked about how we can plug in values. The other thing we can do is we can find some common values. Now, because this is negative, I know that this graph is going to be shaped downward. So that's one thing I know. I also know that if I plug in 0, so to find the y-intercept, if I plug in 0, I'm going to get 0, 6. So anytime I set x equal to 0.
I've talked to him.
Okay. And the other thing we can do is we can find the vertex, if it's not in vertex form, by using the formula x equals -b over 2a. That's actually the first part of the quadratic formula. Remember, the quadratic formula kind of looks like this. So it's just missing that square root. And so we identify what a is. So remember, it's ax squared plus bx plus c. So my a value here is the number in front, or -1. So a is going to be -1. And b is the number in front of the x term, which is just going to be a 1. So it really would be -1 over 2 times -1, or -1 over -2, or 1/2. So my vertex is going to be at the point 1/2. And then I would need to plug in 1/2 into my function, which is g. Oops, positive 1/2. And I would get -1/2 squared plus 1/2 plus 6. Now that's not very much fun. But this would be negative, whoa, goodness gracious, sorry. I'm not sure what I did there. There we go. -1/4 plus 1/2 plus 6, which is actually going to be 6.25. So 1/2 6.25 is going to be right about up here. And the other thing, if I just had found the vertex, is I could find the x-intercepts. And I'm going to do that over here on the left-hand side. So the x-intercepts will happen when y is equal to 0. So if I set the whole thing equal to 0, now I can solve this quadratic equation, which is in another video. I could move everything to the left-hand side by subtracting and adding everything, because I want my x squared term to be positive. So I moved everything to the left. And then I would just have to simply factor and set each factor equal to 0. And that would allow me to find my x-intercepts. So I would have x-intercepts of -2, 0, and 3, 0. Once I have the x-intercepts and the vertex, even without the y-intercept, I can basically, draw my parabola. Now, we will use our graphing calculators to graph some things, but at this point, we just want to review what a parabola looks like and how we make a graph. So my last example is in vertex form. We won't do this example, I don't think, because I want to make this a nice short video. So in this example, we have this in vertex form, and I want to remind you, vertex form is x minus h squared plus k. And the vertex is the opposite value here, so it is h, and then the same value here. So in this case, my opposite value here would be -3, and my same value here would be 1. So I know that the point is -3, 1. And I know, because this is a positive, that it's facing upward. So I can pretty much do a really rough sketch. Now, I could also go ahead and find the y-intercept. So remember, the y-intercept, we just set x equal to 0. And so we would have h of 0 equals 0 plus 3 squared plus 1, or 3 squared plus 1, or 10. So that kind of makes sense, that's going to be here, that this would be my parabola. We could, of course, plug in some other values to get the exact points here, which would probably be here, and 1, 2, 3, 4 here. But that is the general shape of a parabola, in the general way that we do graphing of a parabola.